Dave, is that okay? We'll pick up the normal business after Kevin.
Yes, please. Let's jump into Kevin's presentation.
Excellent. You are good to go, Senor.
Okay, I'm going to share the presentation. Can you all see that? It's coming up.
It is on the screen.
Okay, very good. Well, I certainly appreciate the invitation with the group. I know it's been a while since I've been down there in San Diego. As things have kind of changed this year into the virtual format, we've gone to Zoom as well. So it looks like a good portion of the group is familiar with our company. Some of you are not. We're a manufacturer, Bioenno Power. We're a manufacturer of lithium iron phosphate batteries. And this presentation is an overview with respect to lithium iron phosphate batteries for various types of radio as well as solar applications. Our company's located here in Orange County. We're off of McFadden Avenue. We moved in 2018 to this new location. We're off of Harbor and McFadden, just south of Disneyland. Website's up there as well. Email if you have any questions. So we're founded in 2010. We're a manufacturer of a type of battery that's pretty lightweight. This is a lithium iron phosphate battery. It's about a quarter the weight of a lead acid battery. Has built-in circuitry that protects against overcharge, over discharge, over current. We also provide various types of solar products. We have, for example, solar panels that look something like this that are used for charging the batteries as well. Facilities here in Santa Ana implemented ISO quality standards, I believe offer world-class technology as well as after-sales service. And we do have customers worldwide. This map kind of shows you a little bit of some of our business that we're doing with the federal government, some of the agencies that we currently work with. We're continuing to still do work with DEA with respect to providing various types of power pack products. So we have power pack products that look something like this that are used for powering various types of tablets out in the field. There's built-in inverter as well as battery, solar controller functionality, so you can charge it with a solar panel. They're using it out in the field with various types of tablets and other equipment that they have to recharge. DHS is still an ongoing customer. Still used to power various types of Raspberry Pi computers. So you probably use those at some point. If you're not familiar with the Raspberry Pi, it's basically a postage stamp size, a little bit larger computer that has a CPU, memory, as well as the ability to control various types of controllers, things like that. The Forest Service, a very interesting application of batteries. So why would you think the Forest Service uses batteries? Well, it's an interesting application where scientists, these are federal scientists, they're effectively wearing large capacitors on their back, and they use a battery, a lithium iron phosphate battery, to charge up this capacitor. And they go out to rivers and streams. They stick a long metal rod inside of the water, and fish pop out of the water. And they measure the weight, the length, and the height of the fish, and they throw it back in the water. It's an application known as electrofishing. The Forest Service is looking at various types of applications where they have to analyze different species of fish. Now, this is something that federal scientists can do. It's not something that you can do, but check out electrofishing on YouTube if you get a chance. It's a really interesting application of batteries. Universities, they're continuing business with us where they've implemented a lot of curriculum changes in the electrical engineering fields where they're teaching students about renewable energy, especially batteries, as well as solar applications and how this all integrates together. Oil and gas is a customer industry and customers that we currently deal with. The oil and gas industry, they use a lot of batteries. You may be wondering, why does oil and gas use batteries? Well, on the oil exploration side, there's a lot of equipment that's used out in the field to find these new sources of oil and gas, and they all operate off batteries. And the lithium iron phosphate batteries tend to perform better at those particular temperatures that they require. And we'll share more about that later in the presentation. So what is lithium iron phosphate? Well, you're going to hear different acronyms. It's known as LFP, lithium ferrous phosphate, LiFePO, LiFe. So it's the same type of chemistry. It's just different acronyms for the exact same type of chemistry. It's now considered to be a state-of-the-art battery chemistry, has a tremendous degree of thermal and chemical stability, a very tight iron phosphate ultra-stable bond. enhanced charge cycles, 2,000 to 3,000 charge cycles. And based on what we're seeing right now with a lot of the OEMs that we've done business with over the years, we introduced the batteries in 2012. It's been about 8 years since we have the original ones out there. So the data is starting to show that this chemistry is quite robust in that regard in terms of charge life cycles, in terms of service life. Now, I want to distinguish this compared to other types of battery chemistries called ion polymers. So what's in your phone, for example, this is a typical smartphone. This is a polymer stack battery that's in your phone. This is different than a lithium iron phosphate battery that's usually made up of cylindrical cells. So this type of cylindrical cell that's used to build up the battery packs. They're different in the regards that the iron polymer, it's not as rugged, it's not as robust in terms of charge cycles, maybe about 700 to 800 cycles. So we want to make sure we distinguish lithium iron phosphate from other types of rechargeable lithium battery chemistries. Now, compared to a lead acid battery, so all of you have probably used a lead acid battery at some point. You've seen what happens. A lead acid battery, it sulfates, it vents, it leaks. Lead is quite toxic. Whereas this type of chemistry, a very tight chemical bond. Lead acid battery is quite heavy. This is about a third to a quarter of the weight of a lead acid battery. So, for example, I've got a 15 amp hour battery right here. This is about 4.5 pounds or so, holding in one hand, whereas a lead acid battery, you need a couple hands to hold that. It's quite a bit of lead in there. 200 cycles for lead acid battery versus a lithium iron phosphate battery, 2,000 to 3,000 cycles. Now, with lead acid battery, there's no notion of a protection mechanism. So you can easily over discharge lead acid batteries or overcharge them. Now, you've probably done that at some point. You left your equipment turned on. For example, the voltage drops, let's say maybe down to 7 or 8 volts. You left, for whatever reason, left it on. You found that, hey, I can't recharge these SLA or AGM batteries anymore. And you're not able to recover them that easily. Now with these batteries, it's a little different. There's a circuit board built into it. And what that circuit board does is it protects against the overcurrent, over discharge, under voltage. So let's say you were to leave the equipment turned on at about 10.5 volts, the circuit board shuts off that output. And then the battery's still sitting at voltage. The cells that are inside the pack, they're still sitting at voltage and you're able to recover and recharge the batteries. An SLA or AGM battery, maybe about 50% usable capacity if you were to pull, let's say, 1C. So for example, if you're pulling a 1C discharge out of a lead acid battery, only about 50% is usable. Whereas with these types of batteries, you get nearly 100% usable capacity. With respect to memory effect, we're not seeing any memory effects, so we can charge at 25, 50, 75% state of charge. Now, this is suitable for both cyclic and standby applications. So cyclic means, let's say I charge the battery, I completely discharge it, it goes to its cutoff voltage, 10 to 10.5 volts, the battery shuts off. Or standby if I'm using it for UPS or telecom application. That's called a standby application. So with the memory effects, we're not seeing that, which gets into the partial cycling. So we're not dealing with that memory effect. So the partial cycle, we're not seeing the degradation, and the partial cycle won't count as a full cycle. So if I'm at 50% state of charge, that's considered to be roughly, like charge and discharge of 50%, it's considered to be a half cycle. Self-discharge about a few percent per year. It's considered to be extremely low compared to other types of battery chemistries. This kind of highlights also the fact that with the lithium iron phosphate batteries, I get nearly 100% usable capacity. The lead acid battery, for example, a 12 amp hour battery, maybe only 6 amp hours is really usable, at which point the voltage drops too low. We get a lot of questions about the circuit board and the battery. You know, what does this thing do? Why do you need it? Well, it does a lot of different functions. There's the balancing and equalizations of the cells in the batteries. There's this over voltage protection. So if you apply high voltage to the battery, it turns off that output. You got an overcurrent protection, and then the over discharge protection, which is quite useful. So if I'm at 10 volt mark, the battery's output shuts off, which protects the cells inside the battery, as well as short circuit and then temperature protections. This is a typical battery spec sheet. We can provide this to you if you. We got customers that want to build their own charging systems. So, for example, we can give you. This spec sheet gives you all the parameters to set, so you know what these these charge parameters are. Now, what's important to see here is the fact that the internal impedance is actually quite low, less than 100 milliohms. You'll see that over here. And it's not varying too much with the age of the battery. So that's really important, is you're not dropping across that internal resistance with the lithium iron phosphate. With the lead acid battery, as the battery ages, you start dropping voltage across that internal resistance because it becomes a function of its age, and then it deteriorates more and more, and then eventually that output falls more, and you start needing a lot like battery boosters and things to lift that voltage. Now this is really cool. This is the discharge curve, and what you'll notice here is the discharge curve it's quite flat. You'll notice that, for example, a 12 volt, 20 amp hour battery, maybe if I have a 4 amp discharge, it's sitting right above that 13 volt mark across about 95% depth of discharge. So if around 10 volts, you'll notice it kind of falls at that point and the output then shuts off, but the cells are still protected. So we want to emphasize the fact that if you see the battery turned off, it's not that you killed the battery, it's just it turned itself off. You've got to the cutoff point. It's not, you haven't damaged the battery from that standpoint. So this is very different than a lead acid battery, where you'll know the voltage continues to fall across under a load condition. So that's why with the lead acid battery, as you start pulling more current out of it, the voltage drops more farther. You get that slope. Whereas with the lithium, it's quite flat. So that means we can typically use a very small lithium iron phosphate battery, especially for radio applications. We can use a fairly small lithium iron phosphate battery to replace a fairly large lead acid battery. So that's why we can use a 20 amp hour or 15 amp hour lithium iron phosphate batteries to replace 30 and 40 amp hour lead acid batteries that you were typically using for radio communications. This is an interesting graph showing the available capacity versus temperature. And so what you'll notice here, if you notice on the cold end, around minus 20 Celsius, you'll notice for the lithium iron phosphate battery, we're still above 80% in terms of usable capacity. Whereas with an AGM, absorbed glass mat, a type of sealed lead acid battery, even if at 1C discharge, we're only about 30%. So this is very interesting, especially in the oil and gas industry. They realized that they were having a lot of problems up there with lead acid batteries. You have to use very large lead acid batteries to run equipment, because you have to deal with this derating, right? You have to deal with this available capacity drop at a very cold temperature. So you're using 100 amp, 200 amp lead acid batteries, and they said, well, there has to be something a bit better. So they found that at the cold temperatures for the lithium iron phosphate batteries, they're performing better because you still get over 80%. So they can use a fairly smaller battery for their setups, especially the cold temperatures. Now, if you go to the high temperature range, let's say 40 Celsius or even higher, we can go up to 60 Celsius with these batteries, 143 Fahrenheit. All that capacity is still available, whereas the AGM batteries, you do have also a derating as well at these high temperatures. We get a lot of questions about runtime. So this is a simple calculation with respect to the average continuous power for the equipment. You got our voltage times the current is our power level. So if I have a 12 amp hour battery, so something that looks something like this here, this is 12 volt, 12 amp hours. It's got power pole connectors already attached onto it. You can plug into the equipment. This, if I was pulling, let's say, a 10 watt continuous load, then it would be about 14 hours in terms of runtime. Now, this is a continuous power consumption. Now, with radio, it's actually quite different. And with radio, we're dealing with a weighted average. The radio transmits at a higher power, and we receive at a lower power. Transmit at a higher power, receive at a lower power. So if I have a QRP application where, let's say, I'm doing 10 watts, that's the F, for example, an HF 817, 818, the Elecraft KX2, KX3, the new ICOM 705. This is all going to be in the QRP realm. So, if you're using something like this, a 12 volt, 12 amp hour, you're getting a 40-hour runtime. You get days of runtime off that for QRP. But if you're going to go, let's say, to 100 watt transmission, you'd have to use, let's say, a 20 amp hour battery, and that would be about 10 to 11 hours of runtime. That would weigh about 7 pounds total. So about 6.5 or so. So it depends on what power level you're going to be operating at. And we'll talk more about that later in the presentation. Going to shift gears right now. We're going to talk a little bit about some Go boxes. I know some of you have built various Go boxes using the batteries. This is a W6UIC. You'll see this is a particular Go box. It's built out of a metal briefcase. It's using a 20 amp hour battery with the solar controller. He's able to charge the battery with solar while operating the radio. So you can, again, it's really important is you can charge it while operating at the same time. So that's okay. And you can use a solar panel and install that for under operation. N4KGL is in the top left. This is out in Panama City, Florida. It's using the KX3. And you'll see his team over there. They've got a 15 amp hour battery and antenna as well. This is Tor out in Norway. So Summits on the Air. So if you're familiar with Summits on the Air, it's the competition where you go activate these mountain sites. I'll read what he wrote. This soda hike started from my home Ixis Ranch at 0600 UTC. Took me around 3 hours to get to the summit. The weather today was almost unbelievable with minus 10 degrees and a clear blue sky. The view from the summit almost indescribable. On this activation, I was using an Elecraft KX3 with 5 to 10 watts of output, 2 Bioenno Power 12 volt 8 amp hour batteries, and a buddy stick multiband vertical antenna. I made a total of 153 QSOs on this remote summit activation. 153 QSOs, that's a lot of QSOs, especially at this cold temperature. So this kind of emphasizes the point that we're seeing pretty good operations even at pretty cold temperatures with these batteries. And Tor's has his skis and as well as a tent, and then you build a fire at night when you're doing summits on the air in Norway. Many of you are interested in solar setups with the batteries. It's not complicated. It's quite easy. You need 3 components. You need the battery, you need a solar panel, and you do need the solar controller. So the controller is required. With customers that typically try to attach the solar panel directly to the battery, and the issue is that the solar panel puts out about 18 to 21 volts open circuit under full sunlight. So you need the controller to regulate that input in order to charge the battery correctly. So what the role of the controller, what it's doing is it is taking that high voltage input that ranges between 18 to 21 volts, and it's regulating that voltage to a correct charging voltage so the battery takes the correct charge current going in. So it's important to have that with the solar panel. And that's, I want to distinguish the solar controller that's external product from the internal protection circuit module inside the battery. Okay, so that circuitry in the battery is not a solar controller. That circuitry, what it does is it's protecting against overcharge, over discharge protections, short circuits, and the balancing and equalizing of the cells. So they are 2 different functions altogether. You still need a solar controller in order to charge the battery using a solar panel. How many watts of panel do I need? Really depends on the size. So again, this is, for example, a 12 volt, 12 amp hour battery. It looks something like this. This is 144 watt hours. So 12 volts times 12 amp hours, 144 watt hours. So if I had a 60 watt panel, assuming the battery is completely discharged, it would take about a couple hours to charge. So this is, for example, a 28 watt solar panel. And if you were to chain these together, which you can, there's a port on the back. If you take a look, there's a chaining port where you can plug them together and expand it. This would become 60 watts, or you could use the rigid panels that we have as well, and then charge it in a couple hours if it's completely depleted. So that's one example of a setup that you can have as well. Again, the controller, what it does is it will regulate the solar panel voltage, which is usually about 18 to 21 volts to about 14 volts or so in order to charge the battery properly. This is a very common question. Do I need a special charger for these batteries? We wanted to clarify this. This is a question that comes up quite a bit. So what these batteries are charged with is basically it's a current limited constant voltage power supply. So what we provide with the batteries, and I'm going to grab one here. This is what we provide is a little brick supply. This is a switch mode supply, and what it does is it puts out 14.6 at different charge currents. So, 2 amps, 4 amps, etc. And that what it is that's what the circuit board and the battery is doing is it's protecting against overcharge and over voltage protection and balancing. So that's internalized inside of the battery. So you don't need a fancy balancing charger. So if you're familiar with the radio controlled market, for example, quadcopters or RC cars, you have a fancy balancing charger with a balance connector. You don't need that with these batteries, and you can feed it with something between 13.8 to 15 volts, and then just current limit the input, 2, 4, 10 amps, depending on the model of the battery. Now we pair up these power supply chargers. Our BLF series batteries, they have the BPC chargers that you can get, but there's also other options as well. So if you take a look, let me just see if it's on my desk here. This is the West Mountain Radio Epic PowerGate product. This is fully compatible for charging the batteries. So if you have, for example, a benchtop supply, you could hook it up here. The battery plugs in there, and then you plug in the radio here. So you can use third-party accessories as well for charging the batteries. And with this unit, you can also set, for example, the lithium setting, and then you can set the current limiting here as well on the current limiting side for charging for the batteries. So we have third-party products. There's other ones also available as well. We do have a car charger, which is also, it's a current limited supply. It's actually a buck boost conversion. So from the vehicle, from an alternator source or a stator as a source, and it regulates that charge current and sets the voltage in order to charge the batteries correctly. So just wanted to emphasize on that. And, we see what's the charge voltage for these batteries, what's the open circuit voltage. So again, we're 13.8 to 15 volts. Then after charging, the battery's open circuit voltage, it rests about 13.2 to 13.5 volts. So this matches up with radio quite well. Radio wants to see about 13.8 plus or minus 15%. So you don't need a battery booster with these batteries. It's not necessary, which you might have been using on lead acid batteries. What size of batteries do I need, and how do I know? Well, it really depends on the total power consumption and kind of also the desired runtime. So for example, we're going to look at 50 watts, for example. This is continuous power by the 12 amp hour battery, about 3 hours, 20 amp hour, 5 hours, 40 amp hour, 10 hours, 100 amp hour, 24 hours. That's continuous runtime. But because we're dealing with a duty cycle, this chart will help you in sizing the battery based on the power of the radio, the radiated power. We want to emphasize that's the radiated power. For example, if I have 10 watts transmission, I get about, for a 6 amp hour, about a 12 hour runtime. That's QRP transmission, HF sideband. We're assuming 20% transmit, then 80% receive. And then if you're going to, let's say, 50 watts, so VHF, UHF, simplex, maybe you need the power to get into the repeater, may not. The 12 amp hour battery, it's about 10 hours of runtime. And then a 20 amp hour, about 17 hours of runtime. And then if you're going to 100 watt HF sideband transmission, you do need a larger battery. So 15 amp hour, about 7.5 hours of runtime, and 20 amp hour, about 10 hours of runtime. So it really depends on the power levels that you're dealing with. Most of the VHF, UHF as well as DMR, I would say it's 20 to 50 watts. So 12 amp hour batteries is sufficient. And if you're QRP, you can use very small batteries, 3, 4.5, 6 amp hour batteries as well. But if you're going to go to 100 watts, then you'll need something a little bit larger so you can get the whole day's runtime that you want. We're going to shift gears. We're going to talk about some of our commercial work. We had a lot of requests to include that in the presentation. So we're going to talk about some of the work that we've been doing with some utilities. You guys are down there, so Sempra. So Southern California Gas is up here, so it's the same company, same ownership. So we've been doing some work on some pilots with them with respect to natural gas, these sensors where they have to monitor natural gas coming out of large reservoirs. And so they've got if you look in the middle here, this is, for example, a gas sensor that's used to measure parts per million. And they were using a lot of lead acid batteries in these sites where they can't run up electrical mains or AC mains. We're using the 20 amp hour battery there. This is a data collection unit that they built. It's also a solar controller function as well for charging the batteries. It's kind of interesting application. This is all solar powered. So as you can see, there's a bunch of data loggers as well as enclosures for their particular project. Going to shift gears up to Canada. This is Nanometrics up in Ottawa. This is pretty cool. This is a satellite band, KU band telemetry system for oil and gas exploration. So up in Canada, they don't have, there are places where you go, there's no LTE cellular. Radio packet is too slow. The bandwidth is not there. So you got to go to satellite for running this equipment. So their performance down to about minus 30 degrees Celsius, and they're using 20 amp hour batteries in this type of system. Now, the reason they're using a lot of solar panels is because of the heavily overcast conditions, and their solar day is quite, it's shorter. So you need to charge the battery much more quickly. So that's why there's more solar panels there. We're going to shift gears to a company out in Flow Services out in Shreveport, Louisiana, Laredo, Texas. Same kind of concept. This is a telemetry-based oil and gas monitoring system. This operates on LTE cellular, and they do use radio packet. They can deal with the band, small bandwidth for the information that they're relaying. They're using 20 amp hour as well as 30 amp hour batteries, and they replaced the entire SLA AGM battery legacy system with this particular setup there. So there's some interesting applications there. Some events we've been to, I know it's been, I guess our last event that we were at, we were up in, well, we were out in Orlando in February. So that was before everything started to shut down. I understand that we won't probably see events till maybe next year, or it looks like they're going to try to have events next year. We'll just see what happens from that standpoint. But been to a lot of different things over the years. Some of the cool applications. You'll notice on the top left, there's you can build some go boxes. Another example where you can take the batteries and get like a Pelican style case or Pelican case, and you can put foam in there, store the battery, radio, as well as controllers as well. Take a look at that if you got a chance, as well as CQ magazine, some articles written as well about the batteries. If you want to take a look at CQ, QST articles were written about the batteries as well. And then Stu Thomas, KB1HQS, has written a really nice book on portable operating. Talks about batteries as well as different aspects of portable operation. This might be interesting to look at. We're in other industries as well. So we've been working on other markets over the past several years. Some other markets that we're in include the marine market. We're making headways in there quite a bit in terms of operating fish finders and trolling motors. So we're pushing really hard in that regards. And then also robotics, RVs and campers, as well as UPS systems and other applications. So, and these are some of the new products that we have. We've got some new stuff as well. So we have other foldable solar panels. You can take a look at that. We have like a 40-watt foldable panel. It builds on the same principle as this 28-watt panel. It uses the same kind of very lightweight materials for use out in the field. We had a lot of requests for more portability on the solar panels. So we've introduced 40-watt, 60-watt, 100 light series. So those are available in some. We changed up the whole power pack line to handle higher, USB outputs, just size up the batteries a bit more to meet some run times. And then we've got this 48-volt, 100 amp hour battery for solar storage, new product as well. So if you have a large solar setup and it's 48 volts, you can do quite a bit at 48 volt realm because you start, it's higher voltage, but you're dealing with lower current, so it's more efficient. Inverters seem to run, they work more efficiently in that regards. There is a door prize, so I will let your team figure out the lucky winner. We will ship it out to the lucky winner. It's a 12-volt, 12 amp hour battery with the charger as well, so we'll power supply. So that is the door prize, and you guys can email me who that lucky person is, or if you guys can, yeah, we'll figure this out in a bit, I guess. I guess that's it. I don't have any other things related to the slides. I can pass it back to Dave, or should I pass it back to you? Okay,
yeah, we got a couple questions here in the chat. One person asked, what is the use of the Naval Academy?
The Naval Academy, they've currently doing projects related to solar storage setup. So they're teaching the students how to incorporate correctly sized batteries. They're building some kind of solar controller setups that they're working on out in the school. They're just teaching the students a renewable energy course, elective courses. So it's solar, there's a wind component, batteries is another component in there. So it's part of the curriculum now. A lot of universities have implemented it.
Okay. Another question is, does your battery eliminate the need for buck boost controller?
Yeah, so we don't need a boost converter with the lithium iron phosphate batteries because it's about 13.2 to 13.5 volts. So no need for the converter or buck boost booster.
All right,
Hey,
the other, I think the last question here is, are there any ventilation requirements when using, or can I use them in a completely sealed go box?
Yeah, so there's no outgassing or venting. So it's not like a lead acid battery that has sulfuric acid. We're not dealing with that in this chemistry.
All right, we got a question from John, K6 CPO.
Yeah, I'm interested in knowing what kind of applications they foresee for use in photography. I saw that in your list of future applications. Are we talking about, you know, the typical battery to power a digital camera, or, I mean, what other applications do you visualize?
It's the strobes. So those external strobe packs, the lead acid batteries, they don't keep up. And so we've done replacements. We've used like 20, 30, 40 amp hour batteries to replace the strobe batteries. It works quite well. Quite a few up here in LA, the audio visual and photography markets, you know, they seem to have adopted this chemistry. They're switching over. It works quite well.
All right, any additional questions for Kevin?
I do.
All right,
If
Bruce.
we're done with the rest of the chat column.
Yes.
Hey, Kevin, could you go back and pull up the presentation and go to the consumption chart or life expectancy chart?
Yep. The runtime, right?
Correct.
Yep.
And
It's HF sidebands, yeah, voice. So I just want to clarify that too.
That's fair. And I realize it's a little self-serving, but you know, at some point when you get a chance to perhaps update this chart, if you'd add one more column and make it the 50-50 column.
Okay. Yeah, I'll add that in there too. I'll make a note of that. Sure.
For those of us that contest and FT8 and contest and FT8 and contest, hi.
Yeah, I'll make sure to add the 50-50. I want to make a point. Yeah, the FT8 is a higher duty cycle. So we've noticed that compared to PSK 31, it is a much higher duty cycle. So
Correct.
You will need a larger battery. So it's more 50-50 consumption.
And part of the reason why I'm bringing that up is there's a lot of folks out there that are starting to engage in the new QRP offerings from ICOM. Now that the 705 is out, people are going gaga with the new shiny object out there. And I'm sure you've already gotten questions about how big of a battery you need to go out and buy. And
we do. And I just got it. So
imagine that.
I gotta open the box still.
See, no prompting.
All right, we got a couple other questions here. Go ahead, Bruce.
No, I was done.
All right, how do I care for my battery?
Yeah, so every few months, about you want to make sure every 3 to 6 months to put the battery on the charge, because if you don't charge the battery for more than a year, you will lose the 3%. So we don't want you losing usable capacity on the battery when you can just put it on the charger, so that you don't lose the 3% per year, the self-discharge. That will be permanent if you don't recharge the battery within the year.
All right, we got another question from Chris N1CLC.
Yeah, I posted it in the notes as well. But what's Bioenno has a great product line for batteries. What's your future focus going to be?
So we actually, it's good that you mentioned that. We do have a side of the business that we're doing research and development on various battery chemistries. So we work with various agencies, DoD and DOE, Department of Defense, Department of Energy. It's through a program called the Small Business Innovative Research Small Business Technology Transfer Program, where we're working on new types of battery chemistries, working on an all solid state battery that would potentially be like 7,000 to 9,000 charge cycles. It's in development we're in year 2. So right now we've built some coin cells. So it's very difficult to build this type of, it's not a lithium iron phosphate mix. It's another type of lithium mix, but the electrolyte, it's like a polymer based electrolyte. It uses something called a composite dielectric, and that's what we're working on right now. So we're doing a lot of work in that regard. So hopefully continue that effort. We will continue that effort. We are continuing that effort, I should say.
So I had a couple of comments at the end here, Kevin, and in a variety of social media platforms, the discussion for batteries, portability, batteries for emergency use, batteries for preppers. You know, it often comes up, what are the best brands and manufacturers? And I know I'm not telling you anything that you don't already know, but it's comforting to see that there's a contingent that's very consistent of replies in those forums that Bioenno has been very solid as far as being a reputable company. On the rare occasion when there are problems or challenges, you guys take care of your customers, you take care of product trades and swaps as you need to. There's almost no negative feedback at all. And ham radio operators, being the notoriously cheap bastards that we've been branded as being, you know, there's always folks out there talking about other brands, other manufacturers. A lot of folks are out there, I guess, lacking a better description, promoting a lot of other brands that are coming from various sources out of China via, you know, a lot of the different shippers and other folks that produce stuff from other countries directly. And it's almost a very consistent experience that after those people have had those.
Bruce, you dropped off.
Yeah.
For a number of months, something absolutely goes horribly wrong, and it's come back to bite them. So, and I just got a message saying my internet connection was unstable. How much of that did you guys hear?
Well, you lost about the last minute and a half, maybe.
Well, that was about the whole
portion.
thing. That was about the whole thing.
You said there are cheaper sources out there, and then there was a gap, and the inference is that, and then at the very end it was like, and people regret having cheaped out.
I think
So
you got the gist.
In the middle.
You got the gist of the message. There's lots of other people out there promoting other batteries and other devices coming out of those various sources out of China and other places, I'm sure. And almost invariably, they have reported back after a matter of months that they regret saving the $50 or $100 or whatever it was going to cost them for a comparably sized, what they thought was comparably sized anyway, pack against a Bioenno. So congratulations on keeping a very high profile, high positivity, and very reliable source for the industry as well as amateur radio, Kevin.
Yeah, appreciate it. Yeah, we have a lot. I think it's going to be pretty good. This industry is growing for sure. And there's going to be a lot of developments along that front. And we appreciate it.
We have a couple other questions here in the chat. Is it charged when the light goes green? Yeah, so when the light goes from red to green on the charger, the battery is effectively charged up. So it's basically the charger has stopped delivering charge current, and you can unplug it at that point. You can also do an overnight charge too. So a lot of customers they just put on the charger overnight too, and the next morning they're ready to go. All right, somebody else says, I have a Rig Runner 2008. How do I use one of your batteries as a UPS with that?
Yeah, the Rig Runner. So there was the Rig Runner is a distribution block. There's also some of the Rig Runners and the PowerGate product. There's the PG40S, which is the legacy. It's still sold. It was intended for AGM batteries. There's a charging voltage of about 14.4 volts on the PG40S for charging the batteries. It will work. I haven't seen any issues using the older PG40S. Now the new Epic PowerGate has been set correctly in order to charge the lithium batteries. And again, that's this product here. But if you're using the PG40S, it does work. We've confirmed, checked it out. It will charge the battery as well. This one just has it's full compatibility for lithium iron phosphate.
All right, that's all I see in chat. Does anybody else have any questions? Are there any additional questions? Again, from Fred here, Bioenno has a great customer service, a great help to Sobars, keeping the repeaters online, and I will second that. They work very, very well, and definitely helped the club out a lot.
Sure. And then, yeah, let me know who's the lucky winner. If you don't mind, you could just email it to me, and we'll get that shipped out next week.
All right, Rob, I will put that up to you to figure out how to come up with a winner here, and we can get the information up to Kevin.
We'll talk. Thank you.
All right, sounds good. Yeah, because when this is over, I'll have the recording and also a list of all the attendees, so and everything in chat, so we can work on it from there.
Thanks very much, Kevin.
All right, appreciate it. Thank you for the invitation. I look forward to seeing you guys, hopefully in person, down the line. I think 2021 will be a better year, and we'll get through this pandemic. And so I'm very optimistic. So look forward to seeing you guys. Thank you.
I hope so too. Hope so too. All right. If nobody has any additional questions, we will go ahead and close the meeting for this morning. Thanks, everybody. And thank you, Kevin. Great presentation.
I appreciate it. Thank you.
Thanks, Kevin.
See you.
Quick question. Will you be sending out a link for the recording?
Yes, we'll do that probably by tomorrow.
Thank you very much. Very interesting. Thank you for having the meeting.